This is Kasturi from AD department. So in this video, we are going to see about how to minimize the system complexity. So minimizing system complexity is one of the core objectives in design for manufacturing. So the goal is to create products that are easy to manufacture, assemble, maintain while reducing the number of parts, process and components involved in the system. So a less complex system typically translates to lower manufacturing costs, shorter production times and improved product reliability. In product development, complexity can arise in many forms such as complicated geometrics, excessive parts or intricate assembly processes. GFM mainly focuses on simplifying the product design and ensuring processes in order to make manufacturing easier and more cost efficient. So this approach aims at minimizing the cost of production and maximizing the product quality. So strategies for minimizing the system complexity in DFM, we are going to see one by one. First one, reduce the number of components. So reduce the number of parts in the design by combining multiple functions into fewer parts or simplifying the product architecture. So the main benefit of this structure is fewer parts lead to lower material cost, less inventory management and reduced assembly time. It also lowers the risk of defects or failure due to complex interdependencies between the components. Okay. So second one is the standardize the parts and components. So use standard off-the-shelf components and materials that are widely available and used across multiple product designs. So the main benefit of this is standardization reduces procurement complexity, tooling cost and leads to easier sourcing and inventory management. It also minimizes part variety and simplifies assembly operations. Third thing is the design for assembly. So it focuses on simplifying the assembly process by designing parts that are easy to handle, align and assemble without the need for specialized tools or complex steps. Simplified assembly reduces labor costs, lowers the risk of assembly errors and speeds up the overall production time. Integrate functions into fewer parts, that is functional integration. So combine parts that serve similar or complementary functions into a single multifunctional component. This can reduce the assembly time, material usage and the number of potential failure points in the system. So this strategy can also lower design and manufacturing complexity by reducing the number of required connections, joints or interfaces between the components. Simplify geometries and tolerances. Avoid overly complex shapes and designs that require advanced or specialized manufacturing processes. Additionally, reduce the precision and tight tolerances where possible. Complex shapes can require costly, time-consuming manufacturing process such as precise precision machining or multiple operations. Simplified shapes can be made using less expensive, more widely available techniques. Next one is the design for modular systems. So create products with modular sub-assemblies that can be easily swapped, tested or replaced. Minimize fasteners and hardware. So reduce the number of fasteners like screws, bolts, nuts or eliminate them entirely by designing parts that can interlock, snap or be welded. Design for manufacturability with consideration of technology. So this involves designing products with a focus on manufacturing technologies that are simpler, more efficient and cost effective. Avoid overly complex manufacturing techniques unless absolutely necessary. Next one is the reduce the use of special tools. So minimize the requirement for special tools, jigs and fixtures that are necessary for assembly or manufacturing. Using standard tools or eliminating complex tool configurations simplifies production and reduces the cost. Next one is the consolidate processes strategy. So it reduces the number of separate manufacturing processes required to produce the final product. This can be done by designing parts that can be created in one step or by combining the multiple processes into a single operation. So techniques to identify and reduce the complexity. Value engineering technique. So value engineering focuses on analyzing the functions of parts or systems and finding the cost-effective alternatives that maintain to improve the performance. Next one is the DFM checklist and guidelines. So DFM checklist and guidelines provide specific rules and recommendations that can help the engineers assess whether a design can be simplified or optimized for manufacturability. Design simulation software. So advanced design tools like CAD and CAE, computer-aided engineering, allows engineers to simulate product behavior and manufacturing process before physical production. So what are the benefits of minimizing the system complexity? So lower manufacturing cost. Simplified designs reduce the number of parts, material cost and assembly operations, which directly lowers the overall manufacturing cost. Faster time to market. A less complex design is easier and faster to manufacture, which shortens the production cycles and accelerates the time to market for the product. Improved quality. Fewer parts and simpler designs means fewer operation opportunities for defects, errors or malfunctions during the manufacturing or assembly. Easier assembly and maintenance. Simpler products are easier to assemble and maintain, leading to lower labor costs and reduced potential for assembly related issues. Better scalability. A less complex system is easier to scale for mass production, leading to lower per unit cost at high production values. So in a conclusion, minimizing the system complexity in design for manufacturability and product development is a powerful strategy to reduce the manufacturing costs, improve efficiency, and enhance product quality. By focusing on simplifying parts, minimizing fasteners, standardizing components, and integrating functions, manufacturers can create products that are easier to produce, maintain, and scale. Thank you.